Hello and welcome to my first devlog. I'm currently developing a 3D RPG game, but since I'm in a very early stage right now, you won't see much of the RPG part in the first few episodes. But nevertheless, I will share my journey with you and show you the first technical details and how I get familiar with the Godot engine. So the first part I actually didn't record because I did some navigation, and since there are many high quality tutorials on how to do navigation, I basically followed the video which I linked down in the description. So here you can see how this works. I basically have a CSG environment as a child of a navigation region 3D, and if I close this debug window here, you can see that you can bake the nav mesh and also play around with these settings here on the right. And you can see that if I run the game engine, or the game rather, I can move around. And as you can see, I already have a camera 3D system implemented, but I will get to that later. So the remaining issue is that I want to do the raycast collision with the navigation mesh itself and not with the CSG environment. Right now, when I click here on the floor, it will register every click wherever I do on the mesh. And if you can see here, I can also click, let's see, on this obstacle here, and the player will move towards the obstacle. But if you see inside the engine, there's no navigation mesh. So the remaining thing I want to do is, and I don't know how to do it right now, is to do a raycast collision check on the navigation mesh itself. If we go to the script, we can see that we have here a collision mask, and you can set collision mask. You can check this checkmark here, use collision on the CSG shape 3D, and set the collision layer. And I cannot do this with the navigation region 3D. There's no option for that. Or maybe I'm missing something, I don't know. So even if I don't have a solution for that right now, I don't think it's that important for the first systems I have to implement. And so that's why I'm concentrating on the camera movement system next. But now you may be asking, why am I doing camera movement next? Isn't that very, I don't know, basic? Do you really need it? Because Godot engine has an option to, is this little red button here, project camera override. You can override Runnings's project camera with the editor viewport camera. And if I click on this, it works fine. I can move the camera around inside, and I can also set this window here to be always on top, and I can work with that. The issue is that raycast collisions don't work anymore. So if I click here, the player isn't moving in the right place, and it's because the raycast collision is from the camera itself to the mesh. And since there is now a new camera, so this function here does not transform the original camera, it adds a new camera and synchronizes this new camera with the editor viewport, and that's why the navigation commands are not working anymore. So since I need a camera movement system anyway, I figured, okay, let's implement this first. And that's what I did. So let's see how one might implement a camera movement system in Godot or in some other game engine, since the concepts are very similar. So here I have my scene. I've hidden the background or the terrain and the navigation mesh, so we can see what's going on. This little green capsule here is our player, and this purple thing here is the camera. So first we define I call it watch point. So I take the origin of the player, which is on the feet, and add a vector which is pointing upwards in the positive y direction, like 1.5 meters. So we have a watch point which is pointing at the eyes of the, or the head of the player character. And we want that the camera looks at the head of the player, so we have like a third-person view or an isometric view which is centered on the player. So it works both for third-person and for isometric view in 3D. When we have the watch point, so our head of the player, we can just use a function to look at the head of the player in the camera. This is not the hard part. The hard part is to rotate and position the camera 3D object. So from this watch point, I can add something like a spring, like a camera spring to the head as a vector. So we have the player origin plus the 1.5 meter vector to the head, and then the vector to the camera. So first we have a vector which is pointing upwards in the sky, and the length of the vector is the camera distance, which is determined by the current zoom level. Then we flip the vector around some of the x or z axis. That's the view angle on the camera. And also we rotate the vector around the y-axis, so we have the rotation around the player. And I know it's a bit complicated to explain it here, but when you see it in code, maybe it's a bit easier to understand. So here I have the function recalc position. You can ignore the rest for now, because this function on top, initiate lerp, is for smoothing out the movements and the camera position. And this is responsible for calculating the camera position. So first we have, as I said, the direction upwards in the sky. It's just a vector with length 1, which is pointing up into the sky. Then we have the spring vector, which I calculate by multiplying the camera distance, which is determined by the zoom level, and this direction vector here. Then we have the spring. And now we want to rotate the spring down to the desired camera position. So basically we have this down degrees value, which is basically, I can manipulate down degrees by dragging up and down. So that's what I meant by down degrees. And I also have limited between positive 5 and positive 85 degrees. When we rotated the spring, we have here a check if we are focused on the player, because I've also implemented the possibility that we are not targeting the player. We can move around, like with the WASD commands. And then when we press the button, like the home button, also we can recenter to the player. And that's what's happening here. Then the target watch point is calculated by the transform origin of the player. That's the feet of the player. The player height viewpoint, that's the 1.4 meters above the ground, multiplied by the vector, which is pointing up in the sky. Then we have the distance to target. That's the distance from the target watch point to the target. Then we have the distance to target, and we use that to smooth out the movement to the player. So when we go around and look at something else and press the home button, then it should not jump immediately, because that could look a bit choppy. So it should smooth out the transition, and that's why we are calculating the current distance and starting a lerp here in order to lerping towards the target watch point, which is calculated up here. So just one more thing about the spring rotation. I just realized that I told you that the spring vector is rotated around the z or the x-axis. That's actually not true. So if we are looking like in this direction, for example, and we are trying to rotate the spring vector down, then we have to rotate it around the axis which is perpendicular to our sight lines. So I call this the right axis. You can imagine like a vector which is coming out of that of the player to the right side, and this vector is rotating around as I rotate the camera. And I implemented it in such a way that the vector is automatically rotated when I do the rotation command, and then we can rotate the spring around. Also, another thing, I can reset the camera to a set position. So as you can see, when I rotate the camera around, I can press U and it resets the camera to the default position. And it is also smoothed out. And if you want to track these variables, it can get quite messy. So if we go inside the code, we have the old down degrees, the old forward axis, and the old camera distance. So as soon as I press the button, these three variables are saved. And normally you would do this with global variables. But when you do this for many things, then the global variables list gets quite long, as you can see here already. So that's why I created a closure. A closure is a function which is defined inside another function. So here you can see that I have the function initiate lerp, and here we have the target down degrees, the target camera distance, and the target forward axis. So these three variables define the new view which I want to use. So if we go to the usage of this function, for example here, world reset view, it's an action I defined in the engine, then you can see that I have here default down degrees, default camera distance, and default forward axis. The forward axis, by the way, is defining the rotation around the y-axis. So it's basically a vector which is pointing forward. If we go in this function again, then inside this function, these three old variables, like the old down degrees, the old forward axis, and the old camera distance, are saved inside the function, so not as a global variable. And these can be used inside another function which is defined here. Then we can do the lerp functions. So what lerp is doing, we are having the old value and a new value and a weight between them. So let's say the old value is 0 and the new value is 10. Then we can define a weight between 0 and 1. And if the weight, for example, is 0.5, then the output would be 5, because 0.5 is exactly the middle between 0 and 10. And when we multiply it between the distance between these two values, then we get 5. So that's why I'm using the lerp functions here. We can transition from the old values to the new values each frame. So this initial lerp sets this function to the current lerp function. So normally this function is called every frame, but normally this function is like an empty function, does nothing, it just returns here. And if we call this current lerp function every frame, then we can set it to nothing, or we can set it to this function, which is doing the transition, and it uses the saved values up here. So one disadvantage of this is that you cannot reset these values inside the closure. So that's a downside in GDScript. I don't know if this is by design or if they're changing that in the future. I hope it stays the same, because it helps me here. So I don't have to reset this values, they reset it automatically upon each call, but maybe they will change these in the future, I don't know. So yeah, that's basically it. I'm pretty new to this kind of content. I'm trying to show general concepts instead of going line by line and explaining along while I'm writing the code. Just tell me if you want to go more in detail, the camera movement, for example, or more in detail of some other concepts, or if you like these broader overview type of content. In the next episode, I want to implement a basic interaction system. So, for example, we have like basic level, and we can move the player around and interact with this box here, for example, or do some basic dialogue with an NPC also. And later in the episodes, I of course have to do some artwork. So if you don't want to miss that, subscribe, and we see you in the next video. Bye.